Hello and welcome to the new edition of the HbbTV webinar series in April. We're happy that so many people have registered for this webinar. This could be one of our record attendances. 161 people. I just checked the figures. So this reflects the great interest in UHD services on HbbTV. In other words, using HbbTV as an infrastructure to offer UHD, that's Ultra HD 4K services. We have a great lineup of speakers for you today. Klaus Merkel, Senior Engineer Distribution at German public broadcaster ARD, is working for the affiliate serving the Berlin-Brandenburg region. He's, of course, one of the experts in HbbTV with a long-standing track record, including IRT. So you probably know him from there. We also have Stephen Perrott, Senior R&D Engineer at the BBC. And as the third presenter, we have Rufael Mekuria, who's Lead Research Engineer at Unified Streaming, a streaming and technology solutions provider. You'll hear more about the technical side of things from Rufael. Sadly, we don't have the ZDF speaker with us today for personal reasons. He can't be with us today, but I'm sure we'll have him in one of the next sessions of the HbbTV webinar series. Let's get started. The disclaimer first, as usual. The presentations represent the views of the presenters and the companies they represent, and not necessarily the views of the HbbTV Association. Now, over to you, Klaus. The screen is all yours. Welcome.
Yeah, thank you, Jörn. And I think you should see my presentation now. I'm switching to full screen mode.
Exactly.
Here
Perfect. Thank you.
Okay, so hello, welcome everybody. So my presentation will start with explaining what HbbTV actually does about UHD. So how UHD is incorporated in HbbTV specifications, and you will see my presentation is relatively short, and you will see why this is so. So for the framing first, so in general, the HbbTV specification provides a powerful and even growing toolbox. It doesn't predefine any concrete type of service, though. This toolbox is designed to be really as flexible as possible for all kinds and types of service, and leaves it completely up to the service provider to make something really good of this toolbox. So related to UHD, HbbTV is actually not the main driver for using new codecs or video features. So this is not the role of the HbbTV standardization and specification, but HbbTV takes care to take up new developments in the market like UHD, so to adopt new codecs, adopt new video features like UHD, which become common in the market, and to include them into that, incorporate into the HbbTV toolbox, and make them thereby available for usage for the market within HbbTV applications. So make UHD become a part of this toolbox. Here in this slide, I'm showing you the development of video features within HbbTV specifications, which is a more than 10-year history by now. So if you look at the blue parts, they represent the early versions, HbbTV 1.0, 1.5, and you can see we've started with H.264 as a coding format in the beginning first. The light blue show SD, HD from the beginning, but only via TS delivered, MPEG-2 TS and progressive streaming. We made a big step in 1.5 by adopting Dash for the same video formats, Dash as a transport protocol for SD and HD as well. In HbbTV 2, we started to integrate both HEVC as a codec and also UHD. And in the next version, 2.02, so the darker green one, also HDR and HFR, so higher dynamic range and higher frame rate on top of UHD. And you also see we have started already in HbbTV 2 8.01 and continued this to discontinue older container formats. So MPEG-2 is not supported at all according to the specification for HEVC, nor for UHD, and for the latest version, including HDR and HFR, we are focusing on dash only. So you see a sort of development really focusing on dash, and you see the development from SD to UHD and the related features in HDR. So this is for the big picture and the development in general. So looking a bit closer to what HbbTV really does related to UHD in its specification. So this looks effectively very tiny because HbbTV is taking up a general market development. So it doesn't want to redefine things which have been defined elsewhere. So in fact, the section in the HbbTV specification dealing with the actual video profiles is less than 1 page of a rather thick HbbTV specification as a whole. And the reason is that for all the technical details, there is a general reference to the DVB developments, and there is reference to the DVB dash profile and to the video codec profiles of TS 101.154, so very old and well-known video profile standard of DVB. And effectively, this says that HEVC is the codec for UHD with the corresponding profiles. I've quoted them here. It's all progressive, and you can see the resolution being up to 4K for that profile. So this is the reason why HbbTV can deal with this rather shortly within its own specification. And the idea is, of course, to have a good alignment of developments in the terminals, not to do anything which is not really mainstream and used elsewhere in the DVB market. The specification mandates that UHD is supported in the same way for the HbbTV toolbox as it is supported for broadcast. So that's an important point. So you've seen that UHD is part of HbbTV2, but it isn't so mandatory. But it's mandatory only insofar as UHD is supported for the broadcast part. So the idea is HbbTV2 doesn't force any terminal manufacturer to implement HEVC or to implement UHD. But if the manufacturer does so for broadcast, then the viewer and the service provider can expect that UHD works in the same way within HbbTV applications as it does for broadcast. The specification furthermore defines how applications can read the capabilities. So we have, as you see, we have different capabilities. So simple UHD and then UHD combined with HDR and HFR, or maybe no UHD at all for HbbTV2 devices. So there is a proper definition how applications can read the capabilities of the actual current device. One further thing HbbTV does, it defines bit rates to be supported by terminals. And you see they are rather high and should be really sufficient for the market, up to 51 megabits per second for terminals supporting higher frame rates. So this is quite a lot, and I think more than is actually needed in the market. But one of the examples that are actually defined within HbbTV specifications related to UHD streamings on those HbbTV devices. I'm going to show you now two examples, two snippets of the points that are actually specified by HbbTV. One is the mapping between the broadcast and the dash. So again, you see the broadcast, say, part of terminals, how they, what the options are as defined by 101.154. So how broadcast might support UHD, and you see the pendant for the dash side, which is then the site to be implemented within HbbTV and available for HbbTV applications. And here you see some examples of how the actual indication, which I've mentioned, is done for HbbTV devices towards the applications. So this is the definition how applications can read the video profiles, and you will find here HEVC, you will find UHD, you will find HDR, you will also find the audio options, HEAAC, EBU, TTD as a subtitling format. So you find everything. So the application, in fact, finds everything it needs on the device to see whether it can play a certain stream or has to select other streams potentially for playback. So far the overview what HbbTV actually specifies and does and states related to UHD in its specification. And there is one important thing HbbTV does on top of that. So beyond its specs, this is provide tests for devices. In the latest release of the test suite from this year, so it's rather new, you will find some 75 approved tests dealing with UHD content. So either say explicitly by having it even UHD in the title, or at least using UHD material in some context. Those test cases are quite interesting. So they cover many practical use cases, just beyond a simple playback. So just switching or playing one simple stream, but also testing overlays, testing seeking accuracy, testing all sorts of switching behavior. And you can check out the document where I've put the URL here. So this lists all the test cases of the most recent release of the HbbTV test suite, and you can look there and get your own impression of what is really contained within those 75 tests. And the interesting part, and maybe this is not very well known, that the test suite can be licensed not only by manufacturers, so their main idea is of course to be used by manufacturers, but it can also be used by broadcasters as a reference for content encoding and for application development. I think this is something interesting in general, and this works also for UHD, and you will also find UHD test streams as a part of this test suite. So a final remark, so what does this mean if HbbTV does specify something within its specification? As we have seen, in practice, devices may provide much more features than HbbTV foresees, because manufacturers usually don't have a very tight implementation of the specification. So implementing only exactly what's in the specification, but there will additional things like, or maybe additional codecs in devices. You will find DRM systems, and you will even find UHD in HbbTV devices where they say they are still 1.5 only, which doesn't include UHD, or where it's not in the capabilities. So many more devices actually in the market support UHD than having this indicated by spec, version number, or the capabilities, the XML capabilities, which I've shown you. And sadly, there are also, of course, some devices where the actual device capabilities do not fully cover all the features that HbbTV foresees. So this is also something to be taken into account when doing practical steps in the market. This is not nice, but in practice, it happens like it happens that you find more features than expected. You may also find less than expected. So far for that overview. Finally, I've been asked to point you to that UHD Plugfest, which will happen end of June, which is organized by DTG, Deutsche TV-Plattform. And this covers also this Plugfest, the delivery of UHD content via HbbTV, as you can see in the announcement text. And I've put you here the URL so you can check out by yourself and decide whether this is interesting for you to attend. Thank you very much.
Thank you, Klaus, for this overview and introduction to the topic, the specification, issues, and associated topics. You're based in London, Steve?
Yes, I am.
Okay, that's good. Over to London, I can say.
Are you seeing anything shared yet?
Yes, it's here and it's in presentation mode.
Good. Right. So I'd like to talk to you about the BBC's UHD offerings. So what I will be going through is a look at our proposition, which is what we're offering to the public. Then go over the content that we were using, the application we used to present that, and then a quick look at the live architecture that we were using, the on-demand architecture that we were using, and finally look at some learnings that we gained from these things. So we've been running 2 UHD trials. The viewer proposition for them is the same, that the viewer gets to see UHD versions of some premium content, which they watch through our iPlayer application. Now that is an HTML application, which in particular runs on HbbTV2 devices. And iPlayer streams media using MPEG-Dash on all but the oldest smart TVs. So that meant that we could easily use it to work with UHD. One of these trials provided on-demand content and has been providing high-end dramas and documentaries in UHD. And another trial has been providing live content, which has typically been football and tennis. And both of these are provided only to UHD capable devices. If we look at the content that we've been using, it has a top video representation size of 3840 by 2160. We use high dynamic range through HLG or hybrid log gamma, which is ideal for live production. And we've been using the wide color gamut that's available from BT 2020. Now, both of these things make use of having 10-bit video, and we've been encoding that with HEVC in the main 10 profile. And this combination of these color settings and codec are one of the UHD profiles defined by the DVB and referenced by HbbTV. The frame rate for our content is either 50 Hz or 25 Hz, depending on what the source is. And audio has been encoded using AAC. And finally, our packaging is CMAF compliant and then distributed using the DVB profile of Dash. Now, looking at our application, our HbbTV application runs all the time on our broadcast channels. And it's also available for launching from many device menus. So for anything to do with UHD, the application checks whether it is running on a suitable device. So firstly, we have a list of devices which we know can play the content. The application needs an internet connection to be able to play the UHD content. And then it needs to have or be connected to a suitable display. So on HbbTV devices, we can inspect the video display format capability to determine the video size, transfer characteristics, and color gamut that can be supported. And then we can use the application to provide a call to action. We've been using press red prompts for years, where there's interactive content available on digital TV. And by using this mechanism, as opposed to either a burnt-in message in the video or voiceovers, we can make sure that only people who can actually get UHD content on their TV are prompted. For live programs, we would typically prompt at the start of the program if people are already tuned to a channel, or when they tune to a channel. And for on-demand programs, we prompt people to watch in UHD when the program airs live. We can say you could watch this on demand via iPlayer in UHD. Now the playback is always managed with the UI running in our app, the iPlayer app, but the actual player playing the media could be one of two options. It could be a native player, which is where the device's own Dash player manages the Dash protocol and also the decoding and rendering, or it could be using media source extensions, where we have a JavaScript application which is managing the Dash streaming, and it presents media segments to the browser source buffers ready for playback. Now, in terms of the support for that, MSE support is added to HbbTV from version 2.0.3. Now, just a few more details about the Dash that we're using. We're using the 2014 DVB Dash profile with the live segment profile. So that's using segments, not subsegments, as the addressable unit. And each segment has its own URL based on a segment number. And we're using a fixed segment duration with that. We only have a single audio and video adaptation set, so it's not a player choice whether to choose HD or UHD. That's been decided by the application before selecting the MPD. And we go up to video main 10 profile level 5.1, and for audio we're using AAC low complexity. Now look at our live architecture. So as I mentioned, live events have typically been sports. In particular, football and tennis have been popular. Now, normally these programs go out via our linear channels, for example, the flagship BBC One or BBC Two. However, these channels aren't UHD capable, and so the UHD version will always be processed separately at the moment. Now, in some cases, to start with, we have video going directly from an outside broadcast to our distribution coder, so that's the video link shown on the left here. And in other cases, it may go from the outside broadcast to a production gallery in one of our facilities and then come to the encoders. And in that case, the graphics and things would be added at that gallery rather than at the outside broadcast. We carry out the encoding using on-premises encoders. We have a redundant pair. Each one produces a Dash output as a series of files on its disk. We then read this over the local network by a machine adjacent to it, which repackages the content, does that to tidy up any inconsistencies with the specification or the content, and then repackages it into segments which are DVB Dash and CMAF compliant. These are uploaded in real time to our origins servers together with an MPD. And then finally, the MPD and the segments are available to be served using a CDN or multiple CDNs. Now, we do have some encoding constraints because of doing these live. We only have a small bitrate ladder, which covers the top end of the bitrate spectrum, really. It goes basically from HD up to UHD. So bit rates from 7 megabits a second up to 28 megabits a second in the work we did last year. Additionally, we're restricted to having a 4-second segment duration due to limitations. Normally, we would like to have a value which isn't an integer number of seconds and have an exact audio segment duration as well as an exact constant video segment duration. And the application, or some server logic behind the application, counts the number of simultaneous users for the live streams, and it can limit new joiners to manage CDN capacity. This isn't ideal, of course, but there isn't an infinite supply of capacity that can be used for one-off events, and UHD eats up our HD capacity. Now, also, because of the small ladder, users are given the choice of whether they want to select HD or UHD, since some people may not want UHD if their internet connection isn't fast enough to get a reliable stream. And then separately, we have our on-demand trial. So I'll look at that. It's slightly different workflow. We have file-based delivery of the on-demand assets. And so when we have a HD copy delivered, we will also get a UHD copy for UHD programs. We then use a cloud-based encoder to encode the programs to a flat MP4 file, but with the desired GOP structure that we need for streaming. We then package that into a set of CMAF compliant segments together with the DVB-MPD. And then once that's all complete, we will upload that to the origin servers. And once again, we use a CDN in front of it for the final distribution to the home. Now, with these, we can actually use a 3.84 second segment duration, which is our preferred one, because that allows video and audio segments to exactly align. There's also more time for doing the encoding, which means that we can encode a complete bitrate ladder. In this case, we go from 1.1 megabits per second at the bottom, all the way up to 18 megabits per second at the top. And that in turn allows us to move it from being an opt-in thing to just a replacement of HD content. So where UHD is available, people will get UHD, subject to the ABR algorithms. One thing of interest here is that all the VOD content we've had to date happens to be 25 Hertz progressive, and that's due to artistic intent when the programs are created rather than anything else. Now, these UHD versions of programs generally have the same availability as the HD versions in iPlayer catalog, so people can watch them generally over a significant period of time. And when a program is new, the possibility of watching it in UHD will usually be promoted using an on-screen call to action, like I mentioned earlier. So that covers the technical aspects. I'll just give you a few numbers. So we believe that in the UK, most new TVs on sale are currently UHD capable, and that has now led to about 40% of the main TVs installed in people's homes supporting UHD. Looking at some statistics from our VOD trial, I would say that 60% of UHD playbacks were from HbbTV devices. That was based on an analysis of a series in 2019. And then with live workflows, Euro 2020, which confusingly happened in 2021. For that, in the early group stages, we generally had about 80 to 100,000 viewers for the UHD. After the group stages, numbers increased, but it's hard to come up with a succinct summary of that. And remember that these viewers may sound low, but these are people who entered the iPlayer application and selected to watch the game streamed in UHD rather than just watching the broadcast channel. And I've got a few things that we learnt from the trials. We have surveys open during the trials inviting feedback. Audience have generally said they liked it. We did have some unexpected issues, including some HEVC decode problems, which cropped up on occasional programs. Those were largely resolved with firmware updates to the devices with the decoders. And we've seen the odd thing that look a bit like memory management issues on some native players. And finally, end-to-end tests highlighted where workflows needed polishing. And they really have shown the need for spec compliance at all stages of the chain, and that it's important to do these end-to-end tests, particularly when your chain is significantly different from your normal broadcast channels. And that's it. Thank you for listening to this part.
Thank you very much, Stephen, for these insights from the BBC's R&D department. And of course, as you know, we're happy to receive your questions for the Q&A part. So please do keep sending them in through the chat box. And in the meantime, I'd like to welcome Rufael from Unified Streaming. Let me just quickly share his screen. There you go. And we should be able to see and hear him in a moment. There you are. Hi. Where are you based, Rufael? Still can't hear you. Let me see. Now we should be able to hear you.
Can you hear me?
Yes,
Sorry
we can
about
hear
that.
you, and we see your presentation. Just needs to be turned in presentation mode.
Yes.
And
So
then
I
we're
just
all
want
ready.
to add a little bit to the previous presentations, mainly on some backend standards that you can use to enable a workflow for UHD delivery. So just give me a second. Yeah, so thank you, Jörn, for the invitation, and thanks to the other presenters for the interesting presentation. So yeah, I'm going to talk a little bit about some standards that can help you to enable this UHD streaming backend that Stephen have already been talking about. So myself, my name is Rufael Mekuria. Indeed, I'm a lead research engineer in Unified Streaming, a small software company. So let me just give you a quick outline. I cherry picked some of the standards that I'm going to talk about because those are standards that we actually use at Unified Streaming. So I think we're good to talk about them. So first, I will talk a little bit about the architecture according to -IF. So just as a reference architecture for a backend, we refer to that. It's very similar also to what Stephen showed in his presentation. It just has a few more components. So I'll briefly show you that. And then after that, I will discuss a live media ingest protocol, which is basically a way to connect your live encoders or potentially even VOD encoders, but it's mainly for live with your packagers or origin servers to optimize like your distributed video streaming backend, which is important for UHD as you may want to have some of the higher bit rates produced by different encoders. And other encoders producing maybe the lower bit rates. And then another topic that I related to the UHD backend was the content protection interchange format, which was also developed in the Dash Industry Forum, which is used to exchange key information between distributed entities in the network or the cloud. So I'm going to talk a little bit about that. So this is important for enabling like multi-key. And then I will talk a little bit about some of the custom Dash features and how you can add them on the fly. And then I will mention some of the upcoming standards in this area that I think are also of interest, but they are not yet completed. So just to give a quick intro, so yeah, Unified is a software company, basically streaming solutions for VOD, live, and PVR. We typically sit after the encoder. So it's mainly packaging, stitching, customizing of playlists, and so on. And one positive thing, that feedback that we get from customers and users is that our documentation is open. So you can go to Docs Unified Streaming and see exactly what is supported and what can be done. So that's something that you can look at. Then about myself, I joined in 2016 and I do research and standards. I'm currently involved in -IF, MPEG, DVB, CTA, and I'm currently editing after the DVB Dash standard. So that also was mentioned in the previous presentation. That is mainly used by HbbTV also. So yeah, we are working on the next version that will probably come in early next year, or at least as a blue book this year. And then before that, I did a PhD in CWI in the Netherlands, where I got involved in the MPEG standardization, where yeah, I worked, actually it was part of a paper that I published on volumetric video coding, so slightly different topic. But at the end of this project, actually all mobile device manufacturers joined, the major ones at least. So So that included Apple, Samsung, Huawei, and Sony, and even Nokia and some others also joined. So that's still going on, this work. But yeah, that's kind of how I got involved in standards. So I was, in the first 4 years of my standards work, I was mainly working on volumetric video, but the last 6 years I've been mainly working on streaming standards. So this is the reference architecture that I mentioned about. So this is something that's been under consensus in DashIF, like how a stream an architecture looks like. And the main goal is to define the interoperability point, so that basically you can get interoperability between an encoder, a packager and an origin, a CDN, or an MPD proxy, or a client, or a DRM system. So basically the arrows indicate some of the information exchange flows. I don't think I'm going to go into too much detail on each of them, but basically you start at the encoder and get some input, and that produces content that is basically pushed to a packager or an origin, and then the packager origin produces like well, in some cases just a pass-through, but in some cases it produces a final manifest and a final presentation that goes through the CDN to the client, and in some cases there is an intermediate, what they call MPD proxy, that can change the MPD to have some custom features. So one of them could be insertion of bats, but there are also other features that relate more to the standards. And then an important topic is also the exchange of DRM information. Okay, so yeah, if you look at the documents from DashIF, you can see that, well, not exactly this, but a very similar. I simplified it a little bit, but there's also some more reference to the player platforms that are supported, like based on CTA Wave and so on. But in this presentation, I'm mainly focusing on the backend. So I'm not going to talk about the heavy job. So the heavy job is, of course, it remains the encoding part. So we do recommend to follow the dash, which you may expect from us, and this is also what we recommend to our customers. And well, of course, they can decide themselves what they prefer to support. But the nice thing of DVB Dash is that it has both very strong recommendations for the content preparation, but also some player recommendations. So if a player sort of does things differently than what's written in DVB Dash spec, and we can, create an issue with the player and so on. So I'm not going to talk too much about this. I also know that other people know much more about the video and audio coding specification than I do. But what I am going to talk about is about how to output from the encoder. So this is actually was the first standards project that I did after my PhD. So basically the project on volumetric video was handed over to the industry, basically. So what is the output of the encoder? So basically what I'm trying to show you in this architecture that I showed is basically an attractive idea is to use multiple encoders, multiple origins, so that you can have like failover. And for that, you need a well-specified protocol for ingest. But on the basic level, you even need it to support some of the features that you need to support, like, for example, HDR or HEVC. Maybe you want to move to VVC or AV1 in the future. So for that, we said, okay, the ADR encoder should output, CMAF presentation, CMAF media segments. So for those of you who are not yet so aware of this standard, it's basically a fragmented MP4. So basically what we did here is to use fragmented MP4 as an output of the encoder as opposed to the transport stream. So even DVD, which uses transport stream for broadcast, adopted the IsoBeam and fragmented MP4 for their dash profile. So there is also a TS-based dash profile, but this is not used by DVD. In any case, what we say is that the CMAF specification was completed in 2018. It has pretty good requirements of like what the track formatting should be, how you can signal some of the metadata, and also, compared to TS, you have very clear segment boundaries. So if the transmission of one segment fails, you can just receive an error code and send it again. And then last, there's also a lot of people doing bindings for CMAP, as CMAP was backed by Microsoft, Apple, and then many of the other broadcaster or other companies in the industry. There's basically for any new technology or codec, there is usually some work on providing this CMAP binding. So in a way, yeah, it was, I think, a good choice that we made to say, okay, we should use this as an ingest format, because alternatives like RTMP or smooth streaming that also provide this kind of uplink protocol, they don't really have this future proofness as they provide bindings to new technologies. So they are mostly based on ABC, AAC, and so on. So that's another good reason to look at this idea of doing a CMAP-based approach. So what does a CMAP track look like? So basically, you got your CMAP header, and then you have an optional segment index. And then after that, you get your CMAP fragments or multiple CMAP fragments composing a CMAP segment. So these are basically like the packets or the data units that you send one by one. And the nice thing of it are two things. So first, this is all ISO standards. So no one company can unilaterally decide to change any of this. So with the smooth, for example, you could have some changes that you change your file format. So in this case, it is all standardized. And the second is you have very clearly defined segment boundaries to the delivery. And when you store it sequentially, you will still end up with a valid MP4 file. So this is what we use for the live media ingest protocol. So the specification is available. So the link is here. So it's basically about the encoder sending CMAP media to downstream via HTTP post. This is the main difference. So as you are pushing content out, which is often needed for low latency or, well, for this other reason that I mentioned of these dual workflows, you are posting segments and not HTTP getting segments. So that's why there are some changes required and some behavior needed to be specified. So most of it is based on CMAP, as most information is contained there. But there is still an optional manifest, and that is mainly used to describe the grouping of the tracks, like which tracks belong together as an adaptation set, and the naming. So in Dash, there is a segment template element that you can use to specify the URLs of the incoming segments. So that is used to do that. Okay, so here's what you see. You see the encoder, the CMAP uplink to the packager, the Dash uplink, and then the delivery. So just a last quick summary of that before I move on is that basically it's an easy to work with protocol because it's just HTTP posting or putting a single segment. There is support for distributed workflows. There is support for retransmission. You can use it also for your time text and for your metadata. There are also track formats defined for that, or CMAP bindings for that. There are already some implementations out there, including open source FFmpeg. So we have a demo that shows how FFmpeg can be configured to push this type of content. Also, encoder vendors have been working on it. And basically, by doing this, you can kind of offload your encoder to be like a single point of failure, or to have too many requests to your single encoder. Sorry. This is key to develop a distributed backend, because multiple encoders can be pushing to multiple origins. And then if one origin fails or one encoder fails, it can start up again. And for example, if an encoder fails, it can just start sending again segments. We have some algorithms for that and some work on that. I will come back to that at the end of the presentation. So for now, just to keep it high level and to move on, I'm going to talk a little bit about another standard that's developed in DashIF, which is content protection interchange. So this is an XML-based format that you can use to exchange key information. So this is going actually for an ETSI standard, and there's also a DashIF version of the document. So this can be used to exchange key information between DRM system, packager, and encoder. And having such format especially becomes useful if you want to use multiple keys, because then which key applies when, and to which representation. So that's when CPIX becomes important. So just to give you like a little bit of information, like what is in a CPIX document. So in CPIX document, there is basically a content key. So each key will have like a key ID, and there may also be a secret content key included. So one use case for the CPIX documents is basically to use it in an API. So basically a packager can do a request to a DRM, use a key ID, and then the DRM may send back the secret key in a response. So AWS developed a protocol on top of this called Speak. Some of you may have heard of it. And that's also using CPIX as the exchange format. So another thing that you can specify in the CPIX document is the DRM system. So you may have different keys even for different DRM systems, or you may have the same key for the different DRM system. You may support some DRM systems and some not. So there's some support for that in the CPIX document. And then also there is some optional additional signaling beyond Dash, so HLS and smooth streaming, and even for Adobe HDS. And there is also some signaling of PSSH boxes, which I'm not going to go in detail, but those are basically proprietary boxes that you can include in the file format to signal different aspects of the DRM system. Okay, so here is a very simple example, like I would say a minimal example of a CPIX document. So what you see here is you see the content key element, which has a key ID, and then the secret key is included, base 64 encoded, obviously. So this is basically the key. So this could be like a very simple response or a configuration of a packager to use a certain key. And then in the DRM system, you see there is only there is a PSSH box specified, and there is a system ID specified, which is the white one, system ID in this case. This is a very simple example. Then a second example, which is probably more relevant for UHD, is the multi-key case. So it was a bit bigger, so I actually removed the DRM list. But what I wanted to show is like how you can configure different keys for different resolutions. So basically, CPIX defines something called the video filter. So here we have like basically we have the list of content keys, and then we have this content key usage rule, and then this video filter are based on the pixels. So basically, based on the number of pixels, different keys may apply. So this is how you can configure a multi-key usage in for example, a DRM system could respond to this kind of CPIX document to a packager, and then the packager would know that you know, video up to this number of pixels can use this this key ID, while video with pixels between this and this will use this key ID. So that enables you to do a multi-key packaging. So that allows you to basically have your higher resolution content in different key. So just to support, like we have also published like a simple toolkit to create these CPIX documents. So you can find that on our GitHub page. Actually, my colleague created this. So it's basically, you know, it creates CPIX 2.2 documents. So feel free to check it out. Okay, so that's it on CPIX. I'm just going to add another thing. This is not actually a standard, but this is something that I would like to raise some attention to, is that if you read like the different profiles that exist, is that you can basically add, you know, the different profile have different, may add different elements to the MPD. And in some cases, it's beneficial to do that after the original MPD was constructed. So we call this MPD proxy or manifest edit. So this is something basically that you can add like labels or properties, or even ordering the adaptation set, or even enabling switching between, for example, an HbbC adaptation set and an AGC adaptation set. So there is some signaling for that, but you may need to enable that in a customized way. because you don't know in advance whether it's possible to do this switching or if you want to enable that. So these are all things that could be enabled downstream with the manifest editing. Okay, so that's for manifest editing. Then just some quick preview of some upcoming standards. So one is the TA signaling for DBB dash. So there is an ongoing project going on with SCP and DBB to improve the SCOT35-based add break signaling in DBB dash and also in dash in general. So it's expected to have a first technical specification as a blue book this year. And then second, there is an MPEG call on encoder synchronization. So the DASH-IF has done a joint response to that. And we have also done a presentation of this approach of synchronizing dual encoders in the MHV 2022. So feel free to check that out. And we also have a demo stream available for that. So this is an MPEG project and it's just actually starting while we are speaking. So this is expected for next year to be finalized. Okay, thank you for your attention. I'm going to wrap it up. Sorry if I took a bit more time. So as a summary, we presented the DASH-IF live media ingest for distributed setups. We presented DASH-IF secrets for distributing TVs and some information on this MPD editing and MPD proxying. Okay, thank you very much for your time.
Thank you very much for this report from the machine room, I might say. Very interesting to see these things and the technical side of things, especially. Let me try sharing my screen so I can show you the questions that have come in. And in the meantime, we've also been joined again by all the remaining speakers. So can you see my screen? Should be there in a moment. There you go. Okay, here we can see the questions. So thank you for those. We've got about 5 minutes left, and I think that should be just enough time to respond. The first question, when employing UHD video image, either broadcast or broadband, what about graphics resolution in HbbTV? Is it still in 720? And how do you make composition between UHD HDR video image and graphics rendered by HbbTV application? Who would like to respond?
Yeah, so I think I can do so. So
thanks,
you
Klaus.
can use a higher graphics resolution if you have an UHD device. For the composition, I'm not really sure what the question aims at. So the raster is still 720. So the logic size where you can the grid where you can position your graphics and video windows is still, so there is an update for newer spec, but for the existing one, the grid, so the logical resolution for the HTML side is still 720, but the actual resolution itself can be higher.
Okay.
So it shouldn't be a problem then to have high resolution graphics on UHD devices.
Okay, thank you, Klaus. Next question directly for Stephen. How do you handle low bandwidth issues if UHD content segments representation sets do not mix with HD?
So for VOD, we were encoding down to HD and below resolutions, so that you can mix them. It's just that we weren't for the live trials because the encoder wouldn't produce lots of representations. And the answer there is that if you have a sudden low bandwidth issue, you will end up with buffering on your TV. You know, like if somebody downloads something on your local network, and if you just can't sustain the lowest bit rate, then unfortunately you would have to switch off that stream and decide to play in HD if you needed to stream or watch it on broadcast.
Okay. Next question. What is the typical bitrate for HbbTV UHD streaming? Maybe Rufael, it's a technical question. I think you're muted. Let me check. No,
Sorry, I was.
You've unmuted. You've muted yourself. Okay, here we are. So, Rufael, have you got a response to that, or would anyone else like to give feedback? You should be able to speak now.
Yes. So I think that the UHD typically would be in the 2 to 3 Mbit. But to be honest, maybe other Klaus or Steven can give a better answer because we are not necessarily doing the encoding or checking the bit rates. But I think generally from 1.5 to 3 Mbit would be UHD.
So, Steven, would you have a response to that?
Well, so as I said in our trial, the VOD bit rates varied between 1.1 megabits for the sub HD lower sub HD resolution, up to 18 megabits a second for the UHD resolution. But as I said, that was P25 and it's VOD. Live streaming, our top bit rate was 28 megabits a second last year for UHD at P50, and a ladder going down to 720 P50 only went down to 7 megabits a second. So yeah, it's kind of like you're in the high 20s for full UHD at P50 live.
Okay, so that's quite interesting to see that it's adjustable like that. Next question, I think, is for you as well, Steven. Does the BBC UHD service have any bitrate information?
Well, I assume that was what that.
I think so. That was just covered. Yeah. Unless the question refers to whether you at the end of the BBC have any information about the bitrate being used by the viewers that comes kind of into the living rooms.
I don't have any breakdown information with me at the moment. People were able to receive the top representations, so, but I don't know what percentage we're able to.
Okay, last question. In the BBC trial case, it sounds unbelievable to switch from SD broadcast to HD streaming. Did such a case exist actually? Switching from SD straight to UHD with no HD in the middle, I think that's the point.
So someone was watching a broadcast, they could have been watching it on an SD channel, or they could have been watching it on an HD channel, and I don't know which everyone was doing, but if they were and they went into the application and then chose to stream, they could then stream in UHD.
Yeah, I do think that there shouldn't be really a problem with that, moving from SD to UHD, whatever the local setup is in the viewer's living room. I mean, this is all being offered by you.
Yeah. Okay,
this wraps up the questions. So at this point, many thanks to the speakers for your presentations, the insights and first-hand experiences you have with UHD services on HbbTV. As usual, this webinar will be made available as a recording on the HbbTV Association's YouTube channel, and also the presentations will be made available for download from the HbbTV website. I've just got a couple of organizational messages for you. The HbbTV webinar series will of course continue, and we will announce the topic and date in due course. Also, we will have preview events again and demo events for the HbbTV Symposium. And the first one will be the Symposium Digital Experience, a preview event with selected topics coming to you from sponsors and participants. We will also announce the date for this shortly. And we've already been mentioning it, the HbbTV Symposium and Awards, the 10th anniversary edition, will be taking place on November the 9th and 10th in Prague this year in association with the Czech Association of Commercial Broadcasters, HbbTV. And you might have seen it today. The HbbTV Association has just announced the venue. It will be a historic building in the center, in the heart of Prague, and also the call for sponsors. So if you're interested in that, please do check the latest updates where you will find all these messages, for example, on Twitter and on LinkedIn. And as usual, we are very happy, of course, to receive your suggestions for further webinar topics. So please do send them to webinar@hbbtv.org by email. Thank you again for watching, and thank you to the speakers, and we'll see you again next time. Take care and bye-bye.